All right, good afternoon, good evening, good morning, whatever time it is you might be looking at this. Just hello. Welcome to the Flipped Classroom. This is our beginning of our chapter 3. Just kind of just kind of showing you a little bit what's coming up throughout the chapter. This is actually the entire chapter. There's only 5 sections. Most of this you'll notice is a lot of review of Algebra 2, but that's kind of what we're doing first semester anyway. And you'll notice our very first section, the one we're going to deal with today, is the quadratic function. And I think most all of you guys have your quadratic functions down. So we're going to kind of go through this, kind of look at a few things along the way here. So 3.1, our quadratic functions, couple little things, a lot of little things that we're going to deal with, like the vertex, what the graph looks like, that sort of stuff. But a couple of the big things is writing functions in vertex form, and I think that one's going to be kind of the pieces that we're going to really stress today. So quadratic functions in general, you kind of have to remember a few things here. This is what we are calling standard form. Now, for some reason, the textbook doesn't call this standard form, but every other textbook I've ever read, yes, I've read a textbook. All of the other ones I've ever read they call this standard form. For some reason, textbook uses something else for standard form. We're going to get to that in a minute. So the largest degree or the largest exponent in a quadratic function has to be 2. That's the only possibility. That's what quadratic means. A is what we call our leading coefficient. The ax squared term is kind of obviously called our quadratic term. The linear term is bx. The constant term is called, or our c is called our constant term. And the things we kind of know, we know the graph is a parabola. We always use the letter U to represent this type of graph. And all parabolas have a vertex, every single one. You'll never find a quadratic without a vertex. And that vertex is the highest point or the lowest point on the function, depending on the a value, if a is positive or negative. And there's always an axis of symmetry that goes through the vertex and cuts the parabola in half. So what I want to do right here is just kind of look at just a sketch of what a parabola looks like, just so you have it there in front of you for later use. This is parabola. This is a U up. This is when a is bigger than 0, or when a is positive, in other words. And you notice if a is positive, we have a vertex that is a minimum or a lowest point on the graph. So this is my vertex. And we're going to start calling our vertex h, comma, k. So h is the x coordinate and k is the y coordinate. And then we have this axis of symmetry. It's not a y-axis, x-axis. It's just an axis that runs through the center of the vertex, cutting it evenly in half on both sides. We'll just write in the other type of quadratic as well, or parabola, however you want to think about it. This is the U down, is what we call this usually. This is for a is less than 0. So if a is a negative number, again, we have a vertex that's right here. In this particular case, notice a is less than 0. The vertex is the maximum, or the highest point on the function. And then we have our axis of symmetry. Axis of symmetry. You notice I don't actually write it out because it's kind of long and boring. But whatever. Okay, so that's kind of your general form of a quadratic function. Quadratic graph. So vertex form is kind of that big thing that I want to push today. Vertex form is just another way of writing a quadratic, but it helps us when we graph. It helps us to analyze the function. It helps us in other forms too when we eventually discuss our conic sections. There's a lot of vertex form going on, a lot of completing the square is what we're coming up to, all that sort of stuff that's going on. Okay. So this is what I was mentioning earlier. For some reason, our textbook calls this standard form. Never heard this called standard form before. Maybe I'm just out of the loop. I don't know. This has always been called vertex form for me. It's also been called completed square form because we complete the square to get this form. So one of those things you just have to pay attention to in your textbook when they ask you to write a function in standard form, they actually mean you to write it in vertex form. And this is what vertex form looks like. You notice that HK, that HK is the same thing as what I was mentioning there just a second ago about the HK on our vertex. So I'm going to mention this again. HK is the vertex of the function. You notice, yeah, I'll get to this in a minute. Just the A is the leading coefficient from the original function. So we're going to start with what I call standard form, what most people call standard form, and change it into vertex form. Well, that A that was on the original function is the A in vertex form. And as I also mentioned, this actually describes transformations very well because you'll notice the H here is inside, so that means it moves left or right H units. The K is outside, which means it moves up or down K units. And then the A is being multiplied, which means it's a vertical stretch or shrink depending on the type of number. And if A is negative or positive, you already saw that a minute ago, it flips over the x-axis. It flips it upside down. So what I want to do now is I want to write some functions in vertex form, or like I'm going to keep mentioning is I'm going to write it in standard form according to the textbook. And there are two main ways. The first way is just using the vertex. This just means, hey, find the vertex and plug it in. The second way is completing the square. And completing a square, for some reason, people just don't like it. Maybe it's a little bit more challenging, but that's never stopped us before. And completing a square is actually a pretty good method to know how to do. And in fact, both of them for us are going to be necessary because you're going to be asked to write a function in vertex form using completing the square. I'm going to require you to show me how to do it with completing the square, even though the first one is quote unquote easier. So let's start with using the vertex. The vertex, or the x coordinate of a vertex, is opposite of b over 2a. You may have heard this last year. And the y coordinate is whatever you get out when you plug that number in. So if you plug in the opposite of b over 2a, that y value you get out is the y value of the vertex. So let's go ahead and look at a couple over on my paper here. All right, so let's look at this function y equals x squared minus 3x. Oh, let's not use 3 yet. Mister, that's going to create a fraction. What are you doing? Let's go plus 4x minus 1. Let's make this a little bit easier as our first example here. So I need to find my vertex. So my vertex is the opposite of b over 2a. That finds the x coordinate. Well, in this case, it's positive 4, so this becomes negative 4 over 2 times 1, which is negative 2. And the y value, as mentioned, is just when I plug this value in. I'm going to take this x value, I'm going to plug it in here, and I'm going to plug it in here. So negative 2 squared plus 4 times negative 2 minus 1 is 4 minus 8 minus 1. That's just some simple algebra. And 4 minus 8 minus 1 is negative 5. Now, you got to remember, you can't just stop there because you found some numbers. You got to keep going. You actually have to write it in vertex form. Well, you need to remember vertex form. I'm just going to keep writing this just so it gets ingrained in your head. That's vertex form. Well, I know what A is because A is whatever A was to begin with. A is 1. You can write that in there if you really want to, but you know me, I don't like writing that. X minus H. Well, H is the negative 2. So I'm going to write that as a minus negative 2 just to make sure everybody's kind of with me there, what we're doing. And then plus k, and k in this case is negative 5, so I get a little bit of that, but I don't like all these extra parentheses, so I'm going to say x plus 2 squared minus 5. And there we go, we have vertex form. And right beside this, I want to do one a little bit more, not challenging, but a little bit with more numbers in it. Let's go 2x squared, let's see, plus, we can do 12x plus 7. That'd be a good one. So same idea. We have to get the vertex. So x is the opposite of b over 2 times a, which is negative 12 over 4, which is negative 3. And then I need to plug that negative 3 in. 2 times negative 3 squared plus 12 times negative 3 plus 7 is, let's see, this is 9 times 2 is 18, minus 36. Oh, bet you're all pulling out your calculators right now, huh? Not me. Negative 18, or 18 minus 36 is negative 18, plus 7 is negative 11. Well, that's my y coordinate. That's good. Now I'm going to go back and use my vertex form here. My a is whatever a was to begin with. A was 2, so it's automatically a 2 times x minus negative 3, and I'm just going to write it as plus 3 squared minus 11. And there you go. You got vertex form. All right. So that's how you use the vertex to write in vertex form. Let's go ahead and take a look at completing the square. This is the more challenging version. Kind of the one that people kind of try to not use, but it's one that we need to know how to do. So I'm going to kind of list the steps, and then we're going to go through an example. So the first thing to do is factor out the a from the quadratic and the linear term if there is an a. Then inside the parentheses, if there is one, when you factored, you're going to add and subtract b over 2 squared. It's a very important number for you to know. Then you're going to do a little regrouping, and you're going to simplify, and then you're going to factor the quadratic in order to write it in vertex form. So we're going to go ahead and try probably 2 of them, hopefully. One with an a and one without an a. All right. So let's look at the function y equals x squared plus 4x minus 1. Yes, it's the one we just did, but I want to solve it a little bit different way, obviously, and just to verify we get the same answer. So in this particular case, a is 1, so I don't have to factor out a 1, so that's nice for us. But this is how I set up all of these. If a is 1, I'm going to set this up this way. If a is 10, I set this up basically the same way. So I always write it like this. I say, hey, if I'm going to add something, and I'm going to subtract that same something, and then I got to use my minus 1 here. It has to keep minus 1. Because our properties of algebra basically say I can add something and subtract something without changing it. It's like giving you $5 but taking the $5 away. You didn't get any richer, right? So I can't change my function, so I have to add and subtract the same number. Well, I just have to do what was on that last page there. It says b over 2 squared. In this case, it's 4 over 2 squared, which ends up being 4, because 4 divided by 2 is 2, squared is 4. So I'm going to add 4 and subtract 4 from both sides, or both of those blanks. And then what I'm going to do is I'm going to look at the first 3 terms, And I notice that this is a factorable quadratic in the form x plus 2 squared, and that's the whole idea. That's the goal right there, is to get something squared. And then I just simplify the last piece. Minus 4 minus 1 is minus 5, and you'll notice, because you have it right there, or I'll pull my paper down here, you'll notice those are exactly the same functions. Okay. So let's look at one where a is not 1. And let's do the same thing. Let's use the same function we used a second ago. Y equals 2x squared plus 12x plus 7. So here's where this gets a little bit funky. A, I have to factor out. So I'm going to take that 2, and I'm going to factor out of only the 12, the 2 and the 12. I'm not going to factor out of the 7. I don't even want to use it until the end. So if I factor that out, I'm going to get a plus 6x. And here, before I write any extra parentheses, I'm going to write my plus blank minus blank, and then close my parentheses. And then I'm going to have my plus 7 out here. All right, so I have to do that same thing. Just do a little scratch work over here. B over 2 squared is 6 over 2 squared, which is 9. I hope you all agree with me there. That's 9. So x squared plus 6x plus 9 minus 9, parentheses, plus 7. Now here's where that regrouping line came from, what I said a minute ago, is I'm going to regroup this. I just want to get this x squared plus 6x plus 9 here. And I want to kind of get rid of this minus 9 here. So I'm going to regroup. I'm going to put this 2. I'm going to distribute this 2 all the way over to have a plus 2 times a negative 9. So this is my regrouping. And I'm going to add 7. Just because that plus 7 has to come along for the right. Well, what's nice, you'll notice now, is this quadratic is factorable, and it's factorable exactly like we want. We got x plus 3 squared. Here we have a minus 18 and a plus 7, and lo and behold, you notice what we get from before. Negative 18 plus 7 is negative 11. You'll notice we get the same function here. Okay. Nothing too challenging with it. It gets a little bit weird when you have problems like this. We're not going to do the whole problem here, but if I had y equals 1/2 x squared minus 3x plus 7, and I go to factor out the 1/2, you're not actually cutting the 3 in half. You're actually doubling it because you're dividing by a half. And dividing by a half is just like multiplying by 2. So if I started this process, if I factor out the half, I would actually end up with a minus 6x plus blank minus blank plus 7. And you can finish this one for your own benefit if you want to. You can see me tomorrow if you did it correctly. And yeah, so it's just that when the fractions are there, they get a little bit more challenging, but you've noticed that with just about everything we've done, the fractions get a little more challenging, right? All right. So writing in vertex form, if I give you a vertex and I give you another point, we can kind of do the same thing. We can write functions in vertex form given a few different things. So I have, I think, 2 examples here. So we're going to look at the point 0, 3 with a vertex of -2, -1, and we're going to look separately at the point 3, 2. Sorry, I have to write this down for myself here. And the vertex of 2, 0. So we're going to go to this here. And there we go. So we're going to look at the first one here. So it's kind of like a 1, 2. So problem 1, we're just going to look at, okay, well, y equals a times x minus h squared plus k. We're going to start with that because we're given vertex. So I'm just going to start with what's given. X minus negative 2, right? My vertex, negative 2. So it's going to be x plus 2 squared minus 1. Well, in order to figure out what A is, I have to use that other point that's been given. That other point is the point 0, 3, and that means when x is 0, y has to be 3, so I'm going to just plug those in. And now you notice that a is the only thing left as a variable, so I can solve for that. So 3 equals a times 2 squared minus 1. Add 1 to both sides, I get 4. 2 squared is 4. And I get a equals to 1. So then all I have to do is rewrite my function as, if a is 1, I don't actually have to write the 1, so I get to do x plus 2 squared minus 1, and I missed, well. We're just going to go ahead and go do the same thing for number 2 as well. So just starting with vertex form. Plugging in my vertex. Super nice that k is 0. Plugging in, once I've got my vertex, plug in the other point. I'm not going to write that plus 0 anymore. That's not necessary. Man, I chose easy problems. So notice this thing became 1. 1 squared is 1, so I actually get a equals 2. And I'm going to go ahead and rewrite my function as y equals 2 times x minus 2 squared. If you really want to write the plus 0, like you're compelled to do it, do it. But otherwise, that's your answer. Okay, so going back to the PowerPoint, I think we've actually kind of completed everything I had planned for today. If I can get it to go back to the PowerPoint. I don't know why it keeps bogging out like that. Here's our assignment. If you want to start this tonight, good. I think it's doable in the class period itself, but just come to me with questions if you have. Come to me with maybe constructive criticisms, maybe not too much whatever criticisms on the video itself. This kind of first trial, first run. Hope everything works for you. I hope you kind of get the gist of what I wanted to get over today, and I will see you tomorrow in class. Good luck. Have fun.